Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Today's me and my friend would like to making video about making video that are signed by our math lecturer Dr. Amzari. So first of all, I'm gonna introduce myself. My name is Muhammad Rahimi bin Cedin. My matrix number is 210089 and we are from group 13. So um, today, for this video, we were supposed to talk about our project assignment, which is titled the calculus of coronavirus. So this is our first project that we have done in our first semester. So basically, for our math class, we were given a task which is mandatory for our carry mark for this for this semester. And um, about this, so I'm gonna explain a little bit what is our task or about our task. Um, this task is titled the calculus of coronavirus. We were supposed to produce from this project assignment. We were supposed to produce a prediction on the COVID-19 spread pattern for our engineering mathematics class utilizing a calculus approach that we learned in the class. And need we also supposed to find the daily cases between two countries, and we need to find the infection rate and the recovery rate. So how did I complete or manage to complete the task? So before we step in, there are a few parameters that must be considered, such as the assumption that the total population is constant. So and because the population is vast, we will we analyze the data using percentage. During our project, we apply Excel software to produce a graph that simulated the COVID-19 distribution pattern using the data and function given. I also use SIR model to create a formula to help me getting those to help me predict the COVID-19 spread pattern. So SIR model is basically the short form for susceptible, infected, and removed. So with these three group, I can find the recovery rate and the infection rate by using calculus. So during doing this project, I have find one interesting thing about the project. Here, I noticed that when we compare two situations, rapid and slow infection rate, the slow infection rate is flatter than the slope for quick infection rate. This discovery has piqued my interest, and I'm looking into the significance of the slope discrepancies more. After doing some research, I came to the conclusion that there is a word that medical professionals may use today to guarantee that the pandemic is managed quickly, which is flattened curve. So in summary, after completing the homework or the assignment, I believe I have developed analytical thinking abilities that will allow me to comprehend more deeply when examining the graph and the predicament that the people is facing as a result of the pandemic. So that's all for me. Now I'm gonna pass the mic to the next person. Thank you.
Hello, I do like to introduce myself. My name is Krishna Sivalingam. My metric number is 212664. So let me tell you about our engineering mathematics lesson. We were tasked with writing a technical paper about how mathematics may help in understand an infectious disease outbreak. Our project major title is Calculus of the Coronavirus. The task requires us to conduct research on COVID-19 cases in any country we choose, relating them to mathematics and in particular, calculus. I choose Pakistan for this section to differentiate their COVID cases from Malaysia's. At first, I had no idea how I was going to complete this project. So my first step is to read over Dr. Amzari's notes on the project. He stated the equation and the integration method that we must apply to obtain the outcome, which is a chart of the pandemic in the country that we have selected. I obtained all of the data from Worldometer, and the site states that Malaysia and Pakistan have total population of 33 million and 227 million respectively. One interesting finding from the experiment is that I discovered that this approach is incredibly valuable to supervisors and the general public, since it allowed us to determine the infection rate of a viral pandemic sickness epidemic. As a result, accurate and complete data and analysis are produced. As a result, the information gathered is accurate, and it enables workers to take all necessary precautions to keep the pandemic from spreading across our society. In a nutshell, calculus-based mathematics at modeling is helpful for dealing with the time evolution and pattern of disease outbreaks. This might provide valuable prediction about the disease's spread and help people in preparing to be safe. We may limit the number of coronavirus cases in their population by wearing masks and maintaining social distance, especially in crowded areas, and constantly wash our hands. This is one method of preventing the infection from spreading further. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Zul Haris Putra bin Zulkifli, matrix number 210016. Now, I would like to explain about the task given in this course, in this engineering mathematics course. So, from this task, we are required to write a technical writing about this project, which we are focused about the spread of the COVID-19 pandemic. So we are required to do a comparison between two countries, and I chose to do a comparison between Malaysia and Indonesia. Okay. So from here, from the population, from the people population, we need to categorize them into three categories, which are susceptible, which mean for those who can catch the disease, and the second one is infected, which mean who are infected and can spread the disease, and the third one is removed, which mean for those people who are recovered or who died from this disease. So after we have those separate groups, now we can think about how one group can influence another, and how any of this group can grow or decrease in size more systematically. So in order for us to do this, a few assumptions must be made, which mean n is constant, which is the constant for the number of people. So from here we can derive the we can use the Euler's integration equation method to know more about the infection rate and the recovery rate. Okay. So from the data obtained, we can construct a graph, a susceptible, infected, and removed graph to do a better comparison. So I think that's all from me. Thank you.